Welcome to the Knowledge Bank, where we uncover the science behind the air we breathe. Today, we're diving into a gas you've likely smelled before but never really thought about: hydrogen sulfide, or H₂S. It's the gas behind that infamous rotten egg smell, but there's more to it than just an unpleasant odor. It plays roles in nature and industry, and if not handled carefully, it can be deadly. What is hydrogen sulfide? H₂S. Hydrogen sulfide is a colorless, flammable, and highly toxic gas made of one sulfur atom bonded to two hydrogen atoms. Structurally similar to water, but unlike water, it's corrosive and dangerous. It goes by many names such as sewer gas, swamp gas, and manure gas because it forms in decaying organic matter. At high levels, H₂S can actually paralyze your sense of smell. This gas is highly flammable, with explosive limits between 4% and 45% in air. When ignited, it produces toxic sulfur oxides, worsening air pollution. Being heavier than air, it settles in low-lying or enclosed areas like sewers, basements, and manholes, where it poses serious risks. In the air, H₂S oxidizes into sulfur dioxide, SO2, which then forms sulfates, particles that influence weather and air quality. Slightly soluble in water, it also forms sulfhydric acid, which corrodes metals and contributes to acid deposition. So, where exactly does this dangerous gas come from? Let's take a closer look. Sources of hydrogen sulfide, H₂S. H₂S comes from both natural processes and industrial activities. One major source is crude petroleum. During extraction and processing, crude oil can emit H₂S gas, posing significant health and safety risks. In sewage treatment plants, when organic waste breaks down, H₂S is released into the air, creating potential hazards for workers and nearby communities. Refineries refining sulfur-rich crude oil also generate H₂S, making proper ventilation and monitoring essential. Kraft paper mills, which use sulfur-based compounds in the pulping process, emit H₂S gas as a byproduct, affecting air quality. Even food processing facilities that use sulfur or sulfuric acid can introduce hydrogen sulfide into the environment. Wastewater treatment plants, much like sewage facilities, produce H₂S during the decomposition of organic matter. These sources explain why constant monitoring and regulations are critical to protect workers and communities. And this leads us to the bigger concern: its health and environmental impact. Health and environmental impact of H₂S. Health impact: H₂S isn't just smelly, it's hazardous. Even at low levels, it irritates the eyes, nose, and throat. At higher levels, it causes headaches, dizziness, nausea, and eventually olfactory fatigue, where you lose the ability to smell it, making exposure even more dangerous. At a cellular level, H₂S interferes with oxygen use by blocking cytochrome C oxidase. This can lead to cellular hypoxia, mitochondrial failure, and blood acidification, with life-threatening results. Industries like oil refining, wastewater treatment, and mining face these risks daily. Environmental impact. In the environment, H₂S breaks down into SO2, which then forms acid rain, corrodes metals, and contaminates soil and water. Normally, it degrades quickly, but in colder climates, it can linger for weeks, making its impact more widespread. So, how do we reduce these risks? The answer lies in proper control and corrective measures. Corrective measures for H₂S exposure. The first step is always monitoring, because what we can measure, we can control. improves airflow in confined spaces, preventing dangerous buildup. Install H₂S monitors to get real-time alerts for rising concentrations. Usage of scrubbers and filters helps remove H₂S from gas streams before release. Utilize protective equipment (PPE) to ensure worker safety in high-risk zones. Regular maintenance of equipment and pipelines prevents leaks and minimizes accumulation. By combining these methods, industries can safeguard workers and reduce environmental harm. And since monitoring is the key to all these measures, let's explore how H₂S is actually measured. Measurement methods of H₂S monitoring. There are several advanced methods, each with unique advantages. Pulsed UV fluorescence. It works by converting H₂S into sulfur dioxide (SO2), which, when exposed to UV light, emits a characteristic fluorescence. The intensity of this light helps determine the concentration of H₂S in the air. Lead acetate tape. It is a chemical reaction-based technique. When H₂S comes into contact with lead acetate impregnated tape, it forms lead sulfide, leaving behind a brown stain. The depth of this stain is analyzed to measure the gas concentration. Semiconductor method. This method involves the interaction of H₂S with a metal oxide semiconductor, altering its resistance. This change is measured and converted into gas concentration. While effective, this method consumes more energy than others. Electrochemical method. It is one of the most precise ways to measure H₂S. The gas diffuses into a sensor, generating an electrical signal proportional to its concentration, allowing for accurate detection even at low levels. Each technique has its place depending on the accuracy required and the environment. Hydrogen sulfide may seem like just a bad smell, but it's far more a toxic, flammable, and environmentally harmful gas. From oil fields to sewers, it demands respect, monitoring, and strict safety practices. By understanding where it comes from, how it harms us, and the ways to measure and control it, we can make our workplaces and communities safer. We hope this gave you a deeper understanding of hydrogen sulfide and its importance. If you have questions or would like to explore further, we're always here to help. Stay informed, stay safe, and keep breathing clean.